Hello everybody. In today's video, we are going to be covering on chapter 10.1 on congruent figures. During the previous lesson, we have already learned what does congruent actually means. So when we say that two figures are actually congruent, they are figures that are of the same shape and also of the same size. Okay, so they must both be same shape and same size, then they will be considered congruent. Okay, so when we say that they are of the same size, we realize that there are actually two implications out of it. One implication is that they have equal corresponding angles and also they have equal corresponding sides. Okay, I want to emphasize on the word corresponding, right? Because when we say that two figures are congruent, right? So for example, if I were to say ABC is congruent to, so this is a triangle, ABC is congruent to say XYZ. From the name itself, I will know that A actually matches up with the vertex X, and B matches up with Y, and C matches up with Z. So even if we don't have the triangle itself, I will know 6 different results out of it, which is that the length of AB is equals to the length of XY. The reason is because of AB and XY. Then I also can say that BC is equals to YZ, where BC, YZ, okay, and then also AC is equals to XZ. So because of AC, and XZ. So the vertices actually correspond. And this is where we talk about corresponding sides that are actually equal. Then regarding the angles, same thing actually applies. So let me erase this away first. Okay, so if I say ABC and XYZ, okay, so I can also say that angle ABC will be equal to angle XYZ because of the way that it runs in sequence here. Okay, I can also say that angle BAC, so I went in this sequence BA then C, so I will also go in same sequence YX then Z, so YXZ. And lastly, I can also have, okay, sorry, let me erase this. Okay, I can also have angle BCA, where I have BC then A, so I will also go YZ then X. And this is the result due to the corresponding angles. Right? So this is what congruency actually tells us. So if I were to give you two triangles here, ABC and DEF, and for you to decide whether these two triangles are congruent or not, okay, in this case I did not give any details. So with the very loose idea of the fact that they must be of the same shape and same size, we notice that they are actually of the same shape, and we now have to see whether is it of the same size or not. Okay, so if I can rotate this around, right, I notice that when I rotate it to this point, okay, to this manner, I find that I can actually overlap them very nicely. So I will now be able to see that they have corresponding angles, because you see the three angles actually match up with each other, and also the corresponding sides, okay, are actually equal, where the side on the left matches up, the side on the right matches up, and the side at the bottom matches up also. Okay, they are in fact equal. Okay, they don't just match up, they are equal to each other. So therefore, given these two triangles, I will actually say that, right, triangle ABC, right, so I went A, B, C, will actually be congruent to triangle F, because A matches up with F, B matches up with D here, and C matches up with E over here. So when I write that the two triangles are congruent, this is the matching that I have to do. okay, I cannot write it in alphabetical order. Okay, so when I say two figures are congruent, I need to ensure that the vertices, the letters actually match up accordingly. Because if they don't match up, then it will be very difficult for us to have this conclusion easily from the naming itself. I hope this summary is clear for you with regards to congruency. After we have taken a look at the summary that I have provided earlier, okay, we will now take a look at workbook exercise 10A, pages 112 to 113 to practice these questions 2 and 3. We will first take a look at question 2, where we are given that ABCD is congruent to PQRS. So this is just a reminder, okay, that this is the congruent symbol. Oops, I'm sorry. Let me erase this. Okay, so we're going to be taking, I was saying that this is the congruent symbol. Okay, so you need to be able to recognize this symbol, although we will not be commonly using it. Okay, so you just learn how to spell the word congruent itself. So given that ABCD is congruent to PQRS, okay, that means that the sides are going to be of the same length for both figures, as well as the angles as well. So in part I, we are given that we know that PQ is equals to AB, and we want to know what is the length. So PQ is this side here, and AB is this side here. In the question, we know that this is 5 cm, so therefore it will be 5 cm. Okay, next in part 2, for SR, okay, SR refers to this side here, okay, and it will match up with DC, alright, and we know that DC is 6 cm, okay, which is correct to this information given in the question. So therefore SR is equals to DC. At this juncture, I want to keep you reminded, right? Since we're talking about things that are congruent, okay, we need to understand that the vertices have to match. That means that if I were to erase this, remember that A matches up to P, B matches up to Q, C matches up to R, and D matches up to S. So in writing this down, okay, when we say that it must be S, R, so we must match it to D, C. Okay, hence it will not be accepted if you write CD. Okay, so please be careful in how we write, okay, the letters, the way that it is sequenced when we talk about congruence or similarity. Moving on to part 3, we want to find what is the length of PS and what is it equal to. So PS refers to this length here, so it will match up with AD. Okay, so we know that it will be AD here, and AD is given to be 2 cm, hence the value is 2. So just like in part 2, it will not be accepted if you write DA. Okay, part 4, we have QR. Okay, we want to find out the length of QR and see what is it equals to. So QR refers to this, so it will match up to be BC, and that is 5.3 cm. So we have BC and 5.3 cm. So once again, okay, it is not the same as writing as CB. Next, for angle PQR, okay, angle PQR refers to this angle here, alright, and the question gave it to be 90 degrees, okay, so it will match with angle PQR, so it will match with ABC, okay, so angle ABC, and that is 90 degrees, okay, the degree sign has already been filled in. Okay, so that is how we do question 2. Let us now take a look at question 3, where we want to first determine whether each of the following pairs of triangles are congruent or not. Okay, so given these two triangles, ABC as well as PQR, we need to check whether they are they congruent or not. So of course, okay, on a computer itself, it will be easy for me to actually think about rotating it, alright, to see that when I rotate it to here, I can have two exact copies of the same triangle, right? But of course, during the exam itself, we don't have such luxury of rotation. Then what should you do? Okay, because you can't possibly be cutting out your exam paper and then after that try to rotate it such that your exam paper will have a hole, right? So what we should do, okay, usually I will fix the triangle that is actually on the left side. Okay, so I draw another one that is exactly the same, right? Maybe not exactly, but just a sketch only. Okay, so I can have it that looks something like that. Okay, something of the same orientation. Okay, because it will be difficult to draw one that is exactly the same, right? So now that I have this, I know that, okay, for congruent triangles, the angles must actually be the same. So let me just put in the angles accordingly. So the one on top here has to be 80 degrees. The one here has to be 60 degrees. And the one here has to be 40 degrees. Okay, so in this sketch is supposed to actually represent the one on the right side, because I fixed the one on the left. Okay, I don't rotate it. I'm trying to rotate this one here. I noticed that the one on the right, okay, I have 80, 40, and 60, which are the same angles over here. Okay, so what I will do now, after I have put in the angles already, okay, I will put in the letters. Okay, so 80 degrees matches out with corner P, so I will have the P here. Okay, 60 degrees, oops, I'm sorry. Okay, 60 degrees actually match up with corner Q, so Q must actually be here. And lastly, 40 degrees matches up with R. So I now take information from the triangle on the right. Okay, so I have RQ, let me erase all this, RQ to have the length 6.1 cm, and RQ is actually over here. I will have 6.1 cm. Okay, and then PR has the length 5.4 cm, which is here, and finally 4 cm here. Okay, so now I compare this new sketch. All right, so I rotated the information. Okay, rotate and transfer the information. Then I will compare. So when it comes to congruency, we always are looking at finding equal corresponding sides as well as equal corresponding angles. So I check for these two, okay, and I find that I have my 80, 60, 40 already in place, okay, and 4 cm matches with 4 cm over here, the correct side, okay, 5.4, 5.4, and finally 6.1, 6.1. So I am actually able to confirm that they have equal corresponding angles and equal corresponding sides. So to determine whether they have, or rather to determine whether the two triangles are congruent or not, in this case the answer is yes. Okay, and the reason, right, for it to be congruent, okay, it is because the two triangles have equal corresponding angles and, okay, very important to mention both things, and equal corresponding sides. Right, so this is how we identify whether two triangles are actually congruent or not. Right, I really have to emphasize on the word corresponding, because if you lose out on this word, your answer will lose its meaning, okay, and will not be accurate in explaining that the two triangles are congruent. Right, there will be proofs that you have to learn, okay, regarding proving whether two triangles are congruent or not later on in maybe Sec 5. Okay, so at this point, we are not going to be learning about the proofs, but we still need to be able to identify, okay, or rather we need to know how to identify whether two figures are actually congruent or not. So I hope that this explains for part A sufficiently. We now take a look at part B, and we want to determine whether these two triangles are congruent or not. Okay, so we see that the orientation, okay, the way that the triangles are laid out are rather similar to one another, so there is no need for us to actually do any form of rotation already. Okay, so all we have to do now is to check whether do they have equal corresponding sides, or as well as whether they have equal corresponding angles or not. Okay, so these are the two things that we must always check. Alright, so let's first take a look at the angles part. Okay, angles may sometimes be easier, so we have 80 degrees over here. However, we got a 40 degrees over here and we don't know what is this angle, and we have a 60 degrees here and we don't know what is this angle. Alright, but these angles that are unknown can actually be found. Alright, so we can do that by using our angle properties that we have learned last year. Okay, so for triangle DEF, I can find out angle DFE by considering 180 minus away 80 minus 60 degrees. Okay, and that will give us 40 degrees. Right, and then also when it comes to finding out the angle TSU, we also take 180 degrees minus away 80 minus away 40 degrees, and we will actually get 60 degrees. Okay, so in both cases, we are using the property of angle sum of triangle actually. So this is just a recap of your angle property writing, okay, the reason writing portion. So now that we have already found the angle, this is 40. Oops, I'm sorry. Okay, this one is 40 degrees, and over here is 60 degrees. We see that the angles actually correspond to each other and they are actually equal. Right, so we can say that therefore the corresponding angles are equal. Right, then okay, we now check for the sides. Okay, so for the sides we have 4 cm here and we have 4 cm, 5.39 cm, 5.39 cm, and finally 6.13 cm, 6.13 cm. Okay, so we say the corresponding sides are equal. Right, so because we now see that the corresponding angles and the corresponding sides are equal, okay, we will say that yes, the two triangles are congruent to each other. Okay, in fact, if I want to name it properly, okay, I will say that triangle DEF is congruent to TSU. Alright, take note of the order that I read that. Okay, so I can say triangle DEF is congruent to triangle, okay, TSU. Right, so this is how we ensure that the vertices are actually matching. Okay, and that's all for the explanation for part B. And now lastly, we take a look at part C, okay, where we want to determine whether these two triangles are congruent or not. Right, so we see that, okay, the two triangles, clearly they look rather different, they look like they are of different sizes. Okay, but we should never ever assume that just because they look like they are of different sizes and then simply jump to the conclusion that they are not congruent. Okay, because sometimes the diagrams being provided are actually there to confuse you, so we need to back up ourselves by using the ideas that the corresponding sides, okay, must be equal. Right, oops, sorry, let me get back. Okay, we need to confirm that the corresponding sides are equal, as well as to confirm that the corresponding angles are equal. So let's check the sides first in this case. Okay, for the sides we have 5 cm and 5 cm over here, but we have no information about MN, YZ, okay, as well as LN and XZ. Okay, so in this case, without the information, it seems like it is going to be very difficult, okay, for us to prove that the corresponding sides are equal. So what do we need to do? Okay, at this point, all right, we don't have much skills for us to find out what is the length for these unknown sides yet. So that means that we most probably, okay, cannot do anything about this corresponding sides are equal thing. Okay, that will actually mean that at our level now, most likely we can conclude that these two triangles are not going to be congruent to each other. But let's really check through about these corresponding angles first. Okay, so when it comes to the corresponding angles, we have 70 degrees here, 70 degrees here. Right, seems like it got a chance that it is going to be of equal angles. Okay, corresponding angles are going to be equal. Right, then we check 60 degrees, but we don't have this information. All right, and we have this 40 degrees over here, but we don't have this information. But this unknown, this missing information can actually be found, right, by using our angle sum of triangle property. So let's find out what is angle MNL first. That will be 180 degrees minus 70 degrees minus away 60 degrees. Okay, and we will get 50 degrees. That is applying angle sum of triangle property. Okay, so now immediately we see that if this one is going to be 50 degrees, clearly, all right, there is no equal corresponding angles over here already. So actually, I don't need to go and find this anymore. Okay, so what I will do now is that, okay, I can just go on to conclude that since angle MNL, okay, take note of how I write it, the sequence that I'm writing it, MNL, so I must match it accordingly. YZX, okay, equals to 50, so MNL, okay, maybe I'll just write it as does not equals to angle YZX, okay, because one is 50, the other one is 40 degrees. Triangle MNL is not congruent to triangle YZX. Okay, so this is how we go about saying that these two triangles are not congruent. Alright, so alternatively, instead of trying to find out angle MNL, what you could also do is to have actually found out what is angle maybe YXZ instead. So that will be 180 degrees minus 70 degrees minus 40 degrees. Okay, so I will have 70 degrees over here. So if angle YXZ here is 70 degrees, but this is 60 degrees, okay, clearly they are not equal. So in a similar way of answering this question, so since angle YXZ is not equals to MLN, okay, so YXZ and then MLN, okay, we can say that triangle MNL is not congruent to triangle YXZ. Right? So we just have to choose either one of these formats to write, okay, to conclude that they are actually not congruent.